Hi, now we will go to analytic function. Okay, so far we have found the derivative of a complex function and what is the necessary condition for a derivative to exist for a certain complex function, and that necessary condition was given by Cauchy-Riemann equation. What was the Cauchy-Riemann equation? Ux equal to Vy and Ux is equal to V1 and U1 is equal to minus Vx. So Ux means dou u by dou x and Vy means dou v by dou y, and Uy means dou u by dou y and Vx is dou v by dou x. So this is the short form, and this condition, this is the necessary condition for a derivative to exist, and this is called a Cauchy-Riemann equation that we already studied. Now, what is an analytic function? You will find many places the function is analytic. The word, the function is analytic here and there. Okay? So, what is the meaning of an analytic function? So, if you have a function f of z, if this function is analytic, that means this function has a derivative at a point z, at some point z. That means this function f of z has a derivative at a certain point or at some point z and the neighborhood of this z. So the neighborhood of this z. So in this region, then we call it as this function is analytic. So in simple words, if you have a function f of z, you have a complex function f of z. If this function f of z is an analytic function, if it has a derivative at some point z and a neighborhood of z, then we call it as an analytic function. Okay. So if your function f of z is analytic, means your Cauchy-Riemann condition u of x is equal to v1 and uy is equal to minus vx. This condition obeyed, or this is satisfied. The Cauchy-Riemann condition is satisfied for equation, satisfied for that particular function. So this is somewhat like a litmus test. If you are provided with a complex function f of z and somebody asks you to tell whether this function is analytic or not, what you have to do? You have to just go for this Cauchy-Riemann equation and this condition, and if this condition is obeyed, then you can say your function is analytic. Okay, we will do some example, you will understand it in more clear manner. And when I say about the necessary condition for a function to have a derivative, I told the Cauchy-Riemann equation or this condition is a necessary condition. Then what about the sufficient condition? Because you need to know the necessary and sufficient condition. So the sufficient condition is your ux, vx, uy, vy. These four derivatives, that is dou u by dou x, dou v by dou x, dou u by dou v, dou v by dou y, these all should be continuous. Continuous in a over a region. Okay, if these ux, vx, uy, vy, these are continuous at a certain region, then that is the sufficient condition. Sufficient. So the necessary condition is the function should be satisfied with the Cauchy-Riemann equation, and the sufficient condition is ux, dx, uy, dy, these should be continuous over a region. Then we call the function as an analytic function. Now we will go for a few examples, and meanwhile we will get some more important results regarding this analytic function. Okay? There are some other easier method to know whether a function is analytic or not. Okay, so we will check it. So I will give you the examples. The first example we will do f of z is equal to z itself. F of, first example 1, f of z is equal to z itself. Then what is that? Z is equal to s plus iy. Okay. Then what about f? F is equal to u plus ip basically. So here your u, what is u here? U is your x. Therefore, any complex function you can write as u in the form of x plus u plus iu, and the complex points or complex variable is x plus iy. So our complex function that is given is z itself. So you write u is equal to x and v is equal to y. So we will look for the Cauchy-Riemann condition. What are that? First one is ux equal to dy, that is dou u by dou x is equal to dou v by dou y. So what is dou u by dou x? Dou u by dou x, this is give you 1, and dou v by dou y, that also give you 1, isn't it? So for this function your first equation or first condition is satisfied. And what about the second condition? u y is equal to vx, or minus 1. Then what would be? What would be uy? Uy is equal to dou u by dou y. That is, here there is no y, isn't it? So this is equal to 0. And what about the dou v by dou x? Because here there is no x, so that also equal to. So what does it mean? That is, you can write uv is equal to minus, sorry, this is x, vx. So your first condition is satisfied, and also the second condition is satisfied. So you can say this function f of z is equal to z, that is an analytic function. Okay, so we will go for some other examples. And another easy method you can tell whether a function is analytic or not, that is by looking the function itself. That is, if your function f of z is not an explicit function of z star, that is a complex conjugate, then you can say your function is analytic. That is, if that means dou f of z by dou z star. Z star means the complex conjugate is equal to 0. That means, what does it mean? This means your function is not an explicit function of z star. That is, if your function f of z is not an explicit function of z star. Z star means the complex conjugate. Then f of z is I2. Then f of z is an analytic function. So this is another easy method or one-step method, because if you get the function f of z, you can simply look at it whether this function has an explicit depends on the z star or not. That means on the complex conjugate or not. If it is not an explicit function of z star, then your function is analytic. Okay, so that is another way. So actually, this condition leads to our Cauchy-Riemann condition. We can check it out. So this is easy. How to do it? Because you have your z is equal to x plus I1, and what about the z star? Complex conjugate x minus I, isn't it? Now, if you are taking dou f by dou z star, means dou f by dou z star, nothing but you can write it in this way: dou f by dou x into dou x by dou z star plus, you can just write it like this. You can write because you know the derivative by it's called the partial derivative. You can do it like this: dou f by dou y into dou y by dou z star. So I hope all of you know this. Okay. Now what you need two things. One is, from these two, from the definition of z and z star, you can write x equal to, what is x? You have to add it and divide by 2. So z plus z star by 2. And what about y? Y is equal to, you subtract it and divide by 2i. Z minus z star by 2i. So this is 2, okay? And use it 2i. So you have dou x by dou z star here, dou y by dou z star. So we will find it out from here. So what you will get? Just this will give you dou x by dou z star is equal to, what you will get? You will get half. And dou y by dou z star, that will give you, what about this? That will give you minus 1 by 2i, because there will be 2 minus 1 by 2i, or you can write it as I by 2, isn't it? Because if you multiply with I on the numerator and denominator, you will get here minus I and here minus 1. So this will become I by 2. Okay. Now we are going to split f is equal to u plus I. So dou f by dou x means, dou f by dou x means you can write it as dou u by dou x plus I dou v by dou x. And similarly, dou f by dou y is equal to dou u by dou y plus I into dou v by dou y. Okay. So I am just I am not going to write all those things. You can try at your home. And finally, what we are going to get is ux into half. Okay, just try at your home. Plus uy into I by 2 plus I into Vx into half. Okay, just try on your own, then you will get it because I am not wasting the time. I into V1 into I V1 into I by 2. So this is the things you are getting now. What you do? You separate the real and imaginary parts. So what you will get half into ux. I into I will give you minus 1. So half minus V1 plus. The imaginary part is I by 2 into uy plus vx. Now, what was our condition? Dou f by dou z star is equal to 0. That is the condition for the analyticity what we told. So, dou f by dou z star, can you see this? Equal to 0 eventually leads to the real part and imaginary part should be separately equal to 0. So, this becomes the final condition. Ux equal to V1 and U1 is equal to minus V. This is nothing but our Cauchy-Riemann equation. So you can make use of it wherever you want. That means if you are getting a function f of z, you just look at the function whether this function is an explicit function of z star or not. If it is not an explicit function of z star, you can say this is an analytic. Okay, so that is another way to find out. But generally, you can just look at the Cauchy-Riemann equation, and if it is satisfied, then you can say without any doubt that function is analytic. Okay, and now I will do one more example, and after that I will give you few homework you have to do at your home and send me. So the first example, f of z is equal to z square. So this is small example. Here what you do, first you make it in a simpler form, that is in the form of u plus I. That is, you just separate the real and imaginary part of this function. So what is z? Z is equal to x plus I1. So z square is equal to, we already done it in many times, and I am not going to repeat. X square minus y square plus I into x1. So here, this is your u and this is your v. So what you need? You need to check the Cauchy-Riemann equation, and that will give you dou u by dou x. What is dou u by dou x? Dou u by dou x is equal to, if you take the derivative, 2x, and dou v by dou y. What will be dou v by dou y? That will also give you 2x. So your first condition is satisfied. This is u x v y. So this is okay. Now, what about dou u by dou y? Dou u by dou y, you will get minus 2y because you have x square minus y square is equal to u. So dou u by dou y is minus 2y. And what about dou v by dou x? Dou v by dou x, because v is equal to 2xy, so dou v by dou x is 2y. So what about this? So this is u1 and this is vx. So this will be fine because this will give you u y is equal to negative of vx. So your second condition also satisfied. So you can say this function f of z is equal to z square is an analytic function. So I will give you 4 or 5 examples to do, but yeah, because that much time only we will get. So another example is f of z is real. So what is this? Z is equal to x plus I1. So real part of z is x. So your function basically f of z is equal to x6. So what about this? When you compare with the u plus iv form, your u is equal to x and v is equal to 0. Then when you take dou u by dou x equal to 1 and dou v by dou y is equal to 0. So the first condition is satisfied. So if one condition is not satisfied, no need to check the second, because that means here you got ux not equal to v1. So this is not an analytic function. So this is one way. You can also look at it in a different way. How to get it? Because your function f of z is equal to x. So this is z is equal to x plus I. Then what about z star is equal to x minus I1. So what about x from this? From this one, x is equal to z plus z star by 2. Is it? So I am writing that z plus z star by 2. So look at this function. This function above z is equal to z plus z star by 2. That is, this is an explicit function of z star. So obviously, it should not be an analytic function by our definition. Okay, so that you got it from the Cauchy-Riemann condition. Okay, now I will give you the examples. I am writing it here. You do all the works at home and send to me. So one example is f of z is equal to a raised to z. Homework is our homework. Can you see this? So f of z is equal to sin z. Sin z. Then third one, f of z is equal to s square plus r by 2. Then you have f of z is equal to f of z is equal to s square plus 3 by r. Okay. So these are some of the examples that I noticed. You can do it all and send to me. And there is one more. These are the things. Homework. And another thing, something like a function like ez or sin z. Certain functions, they are analytic for the whole range of z value from 0 to infinity. Then this kind of functions are called entire functions. So the definition is, if f of z is analytic for the range z less than infinity, that is all the value of z. If the function is analytic. If the function is analytic for the entire range, that is ranging less than infinity, then this function is called and their function. So sin z, e raised to z, z square, these are some of the examples for and their functions. So I am just winding it here.